Alright people, welcome back. So in today's episode we continue our journey with dynamic programming, and in today's episode we deal with problem 740, delete and earn. So let's see what this problem is about. You're given an integer array nums. Okay. You want to maximize the number of points you get by performing the following operation any number of times. Pick any nums I and delete it to earn nums I points. Afterwards, you must delete every element equal to nums I minus 1 and every element equal to nums I plus 1. Okay. Return the maximum number of points you can earn by applying the above operation some number of times. Okay, so first we have to come up with the best strategy before implementing that. So input nums equal to 3, 4, 2. Output is 6. Why? So for sure deleting 3 is not the best thing to do, because then we have to delete 4 and 2 and we go away with just 3 points. You can perform the following operations. Delete 4 to earn 4 points, consequently 3 is also deleted. So nums is equal to 2, and delete 2 to earn 2 points, and so the total is 6 points. I think we can do also that the other way around, so we can pick 2, then 3 is eliminated, and then we can pick 4, and then we get to a total of 6. Nums equal to 2, 2, 3, 3, 3, 4. The output is 9. So I suppose we can pick 3, then 2, 2, and 4 get eliminated, but we can pick 3 and 3 again. So if we pick 3 times, we get to 9. Well, if we do that with 4 and these 2, we get to 8 as a sum. You can perform the following operations: delete 3, delete 3, delete 3. So you see, in this case, for example, we have an example where it is clear that picking the highest number is not necessarily the best strategy. In these two examples, we have the same the same 3 values, but some are repeated in such a way in the second examples to change our strategy. So here we pick 4 and 2 and we remove 3. Here instead we take all the 3s and we remove the 2 and the 4. So now the idea is to return the maximum number of points we can earn, and of course we need to use a dynamic programming approach. So just a few ideas just to come up with something. Suppose that I have a sorted array like this, okay? Then some of these numbers may repeat, but this doesn't matter. What I noticed here is that either 2 or 3 must be picked, because of course not picking 2 may imply that we pick 3, but let's say that we don't pick 3 because we pick 4, then 2 must be picked. So it's like we have to choose one of these, the first 2 numbers, and this repeats, like this pattern repeats. So suppose we choose 2, then we can either choose 4 or we can choose 5. But of course, we cannot choose none of them. Like if you select 6, then it's straightforward that you must select 4 because it's there. Okay, what you can do instead is to select 5, and then of course you would select 7. So it feels like the numbers are divided in couples. You must select one of these 2, and you must select one of these 2, and you must select one of these 2. Of course, this as some, like for example, suppose that we choose 3, then it's not necessary that we pick 4 or 5. It's like we shift to 5 and 6. So at this point, the new couple from which we have to choose is 5 and 6. So basically, suppose that now we picked like a certain value, let's call it key, okay? Now we basically have to choose whether to select key plus 2 or key plus 3. Okay, but how do we actually... Okay, but I don't know if this is bringing us to something. Is there an hint or anything? Because I really have no clue. So let's see. If you take a number, you might as well take them all. Keep track of what the value is of the subset of the input with maximum m when you either take or don't take m. What does this mean? I think what the hint is saying is that basically for each subset, like increasing the maximum, we can calculate the best strategy, and that can be updated easily. Because, for example, let's say that we start with 2 and 3, right? So the best strategy is to pick 3. And now what's the best strategy with 2, 3, and 4? Is to either pick the strategy with 3. So this array is ordered, right? So either we pick the strategy with 3, or we pick the strategy with 4 and the strategy with 2. So for example, suppose that we are at number 6, and like we increment from 2, 3, 4, 5 to 2, 3, 4, 5, 6. Now the best strategy is either the best strategy like found before, or the strategy that it must include 6, and then we have to choose between the best strategy for 4, for 3, and for 2. Let's say the best strategy found until 4. Yes, I think that's the best way to proceed. So let's call it. So the idea is we have 3 different. What's the name of the? How do we want to call it? Maximum. Okay, so we can call maximum 1 is basically okay. So first of all, we sort the list. So we would go with nums sort. Now the maximum 1 is actually nums 0. Okay, then maximum 2 is equal to. Oh, actually we have to count. When in an array the same value appears more than twice. But for a second, suppose that we deal with an array where there are no duplicate numbers. Suppose that we have an array with no duplicate numbers, so we have that maximum 2 is equal to nums 1, and then at this point maximum 3 is equal to, like, we have a for loop, so let's say for I in range, and then we start from 2 and we go to n, where of course n is the length of nums, and we say we say simply that the maximum 3 is equal to the maximum between maximum 2. Actually we need 4 maximums, because we want nums 0, nums 1, nums 2. Yeah, I think that in principle it works if we don't insert duplicate numbers. So the maximum 2 is equal to the maximum between maximum 2 and no, because if we have no repetition, then of course the best strategy is to pick 7, 5, 3, like independently of the sequence. Okay guys, so I took some paper to write down a few examples. I think at this point we can delete this because this doesn't work. I don't know if it is the best way to proceed. What comes to my mind is basically to create a sort of array which contains the gains we can take for each index. So for example, we have values that go from 1 to 10 to the 4th, right? So let's say that at index 0 we get the, so for example, just to give you an idea, suppose that we have an array like this. So it's 1, 1, 1, 2, 4, 5, 5, 6, 7, 8, 8, 10, 15. Okay, let's call it 13. So the idea is I want to create an array which contains my earnings for each, like the index represents the earning I can get for the corresponding value. So for example, index 0 is the earning I can get by taking 1 as a number. So I get 3 as an earning because I have 3 ones. Then I get 2. Then I get 0 because I have no 3 here, right? Then I've got 4, then 10, then 6, then 7, then 16, then 0, then 10, then 0, then 0, then 13. Okay? Do you see the idea of the gaining array? And once we have this gaining array, this gains array, well, actually, once I have this array, I can definitely implement the strategy that I was mentioning before. Let's see if I can save this and go back to the previous algorithm that I was writing down, because I think at this point this works. So just to give you a rough idea of, yeah, this is the example we had. So first of all, how do we create this array based on the array that we have at the beginning? So I think we can do something like for nums. I think we need to create like the array gains, which is literally 0 times n. So n must be declared before. Yes, actually to be commented out. Okay, so n is equal to the length of the numbers. We define gains. Actually, maybe this is better if we have n minus 1 values. No, I'm sorry. Actually, n is better. No. We should not multiply by n. We should multiply by the max, let's call it max value, which is equal to the max of nums. And we must multiply by the maximum minus 1, right? So that at this point, we have that the array is long as the, as going from 1 to the maximum value. So for num, in nums, we just get gains num plus or equal num, definitely. So if the num, for example, is 1, actually gains num minus 1 plus or equal num. And then we get to gains. At this point, we can now define the maximum with strategy 1 as 3, the maximum with strategy 2 as nums 1, and then for I in range to n, actually the maximum 3 is equal to nums 2 plus nums 0, definitely. This is the way it's done. And at this point, we can say that for I in range, let's say 3n, the new maximum 3 is equal to the maximum between maximum 3 or maximum 2 plus nums plus, actually, not nums, this is wrong, this is gains. So the gains I, or maximum 1 plus gains I. And then I can redefine maximum 2 as, let's call it maximum current, let's call it maximum prev, and let's call it maximum prev 1, 2, and then there is current. I don't know, what should I do now? Maximum 2 is equal to what? It's the previous maximum current. So maybe we can save it temporary. Maybe yes. And then we return the max between maximum prev 1, maximum prev 2, and maximum current. No, we just return maximum current. I don't know if this works, really. Not sure. Not really sure. Let's see. Runtime error. List index out of range. So num is in nums. So gains of, like, if num is equal to 1, then I'm accessing gains 0, and this is reasonable. If num is equal to the maximum of nums, I am accessing the index max value minus 2 or 1. I think actually here we don't need that. I think now it will work. This is so wrong. Let's call it prev 1. The terminology was not consistent. Let's see now. List index out of range. Let's see. Of course, because I want gains I minus 1. I want gains I minus 1. Let's see again. List index out of range. That's crazy. Let's try again. It's simply wrong. Which is really fantastic. That's because we should not follow the... we should actually follow, like, from 3 to the maximum value minus 1. Let's see again. Now, in case 2, we get the right answer. Well, in case 1, we output 3. So let's see what happens in the case 3, 4, and 2, right? In the case 3, 4, and 2, the maximum value is equal to 4, and the length is 3. Actually, we don't need n for anything, don't we? No, so we can forget about n. And we can literally forget about nums. Yes. So the maximum value is 4. The gains appears like this. 0, 0, 0, 0. Now for num in nums, gains of num minus 1 plus or equal. So we end up with something like gains is equal to 0, 2, 3, and 4. Now the maximum here is 0, the maximum here is 2, and the maximum here is 3. Okay? Now for I in range 3 and the maximum value minus 3, minus 1. Okay. So here is because it's not correct. I shouldn't have maximum value -1 here. Yeah, that's it. Let's submit this and let's see if it works. Runtime error. List index out of range. Okay, so if you tell me, oh, that's incorrect. If nums actually better than that, we can simply do something. We compute the gains, but let's say if max val is less or equal than 1, actually we can do it maybe here. If the length of gains, or maybe not, maybe we first store the variables, but no, the problem was created here. So if gains, like the length of gains is less or equal than 2, 3, like if it is 3, it's okay. If it is less or equal than, if it is equal to 1, then we return gains 0. If it is, if the length is equal to 2, we return the maximum between gains 0 and gains 1. And if not, we're okay. So let's try again. Let's submit. Oof, again problems. Okay, this is incorrect. Let's try again. This is a syntax problem. Okay, so the output here is not correct. Let's use this test case then. Okay, so this is the test case. 1, 1, 1, 2, 4, 5, 5, 5, 6. So in this case, the max number is 6. Gains will be something like 0, 0, 0, 0, 0, 0. For num in nums gains num I, so at the end we will have something like 3, 2, 0, 4, 15, 6, right? Now if the length of gains is equal to 1, we return gains 0. If the length of gains, okay, this is not happening, so now maximum prev, this is equal to 3, this is equal to 2, this is equal to 3. So now what's the problem now? So temporary will be equal to 3, then the maximum is going to be to the maximum between maximum current, which is 3, or 2 plus 4, or 3 plus 4. So this is going to be 7, right? Now the maximum, like this is going to be updated as 2, and this is going to be updated as that's incorrect. This has to be updated as temporary, because otherwise it doesn't work, because it has to take that value. That is the reason why it didn't pass, isn't it? Okay, we had to do a bit of debugging, guys, a bit of debugging. Okay, let me clean here a bit of extra comments. And I think this is a pretty long algorithm, to be honest, maybe too complex for our needs. At the moment it passes. Let me see if there is any need to do that in a specific time or complexity or memory complexity. So in this case, here this is already on. This is already on in space. So we're already in the first two lines we get to on in time and on in space. Then this is on again, but doesn't matter. Nothing. This is already on. So in the end, it's on memory-wise and on time-wise. Actually, it's not just on, because like this is on, but this is, let's call it key, like where key is the maximum value. So it's going to be on plus key, something like that. Actually, no, it's either on or o key, depends on which is bigger. Let me see if we have, both, like num's length is greater than like the values in nums. So the real complexity is on. Yeah, definitely. I think that we don't actually need to have 3 values. We may actually need just one. So something like we remove this, we call this prev, we call this current, we remove this, we remove this. I don't know if this works. If it does work, I don't really know even how. And indeed, we got wrong answers. Fantastic. I think we must do the maximum between gains 1 and gains 0. Could it be because of that it doesn't work? Now we got a good result here. The output is 18. What's the problem here instead? That the range must start at 2, probably. Yeah, now it works. Now it works. That's crazy. That's literally crazy. Okay, the reason why I came up with the idea that we couldn't remove the third is because I remember that in the previous problems we encountered, we didn't have to store 3 values, and it feels that we are using the same approach, but I don't really understand why, like, logically this works. Okay, well done. So I think at this point we can conclude with this new problem. I feel a bit confused, but I have to think about it. The memory complexity and the time complexity stay the same. It's ON. So thank you very much, guys, for watching this video, and see you in the next episode.